In this video, you'll learn about the rules in finding the derivatives. To find the derivatives, several rules are applied depending on the function's form, and these rules provide shortcuts for differentiating various types of functions, avoiding the need to repeatedly use the limit definition of the derivative. So let's start with finding the derivative of a constant. So the derivative of a constant, let's say our constant is c with respect to x or dx. So let me just write it this way. So derivative of a constant with respect to dx is equal to 0. So let's say we're given this function y equals 4. So the derivative of y with respect to x or dx, this is just equal to 0. Okay, let me just remove that. How about when y is equal to 2000? Right, so the derivative of y with respect to x is still equal to 0. So no matter how small or big the number is, when it's a constant, the derivative of that is equal to 0. Now let's talk about the power rule. So the derivative of a power with respect to x, let's say x to the n, is just equal to the exponent, our exponent here is n, times x to the power of the exponent minus 1. So let's say we're given a function that is equal to x squared, y equals x squared. So derivative of y here with respect to x is just equal to 2, the exponent, times x to the power of 2 minus 1. And this is just equal to 2 times x to the 1, or simply 2x. Now let's say we're given the function y equals x to the 6th. So the derivative of y here with respect to x is equal to 6x to the 6 minus 1, or 6 times x to the 5th. Now how about the derivative of a constant times a function? So derivative of a constant, so our constant c, and a function, let's say the function is f of x, with respect to dx is just equal to the constant times derivative of f of x with respect to x. So when you're given a function multiplied by a constant, you can just put the constant outside or factor it out, and then you get the derivative of the given function. So let's say we're given this function y equals 2x to the 5th. Then we solve for derivative of y with respect to x. So this is just equal to 2, the constant, times the derivative of x to the 5th with respect to x. So this would become 2 times derivative of x to the 5th. We use the power rule. So the exponent, which is 5, times x to the 5 minus 1. So this is 10x to the 4th. So this is the derivative of y equals 2x to the 5th. How about we're given this function y equals 3x cubed? Then we get the derivative of y with respect to x. So this is just 3, the constant, times the derivative of x cubed with respect to x. So this is 3. We use the power rule for this. times the exponent, which is 3, times x to the 3 minus 1. So this is 9x squared. So 9x squared is the derivative of y equals 3x cubed. Now, how about the derivative of sum and difference? So derivative of sum and difference. So let's say we get derivative of one function u plus minus another function v with respect to x. So this is just equal to the derivative of u with respect to x plus minus the derivative of v with respect to x. Right, it should be v. So let's say we're given this function y equals 5x squared plus 3x minus 2. And we get derivative of y with respect to x. So we will just simply use the previous rules that we've just discussed. The power rule, the constant times a function rule, and derivative of a constant. So we get the derivative of each of the terms. So we have 1, 2, 3 terms here. So we find the derivative of 5x squared first. So this is a constant times a function x squared. So that is 5 times x squared. We use power rule. So this is 2 times x to the power of 2 minus 1. Plus derivative of 3x is just 3 times the derivative of x with respect to x minus the derivative of 2 with respect to x. Sorry, I should have written this in this way. Should be so you won't be confused. Derivative of x squared with respect to x, and then we get the final derivative of that is 5 times derivative of x squared is 2 times x to the 2 minus 1 plus 3 times derivative of x. This is x to the 1, so that is 1 times x to the 1 minus 1 minus derivative of a constant is 0. And then we further simplify that, and this would become, okay, derivative of y with respect to x is equal to this one 10. 5 times 2 is 10. Then x to the power of 2 minus 1 is just x to the 1, or simply x, plus 3 times 1 times x to the 1 minus 1 is 0, and x to the 0, any number or terms or variables raised to the power of 0 is equal to 1, then minus 0. Therefore, the derivative of that function with respect to x is just equal to 10x plus 3. How about we're given this function y equals 3 halves x cubed minus 3x plus 28. And we get the derivative of y with respect to x. So we derive each of the terms here. So we derive this first. So this is 3 halves. Then derivative of x cubed with respect to x minus 3. Then derivative of x plus derivative of 28 with respect to x. And this is just 3 halves. Derivative of x cubed is 3 times x to the 3 minus 1 minus 3 times derivative of x is 1 times x to the power of 1 minus 1. Plus derivative of a constant is 0. Then this is just a derivative of y with respect to x. So this is 3 times 3, 9 over 2. Then x to the 3 minus 1 is 2, so this is x squared. Minus 3 times 1 is 3, times x to the 1 minus 1 is 0. So this is x to the 0, therefore that is just 3 times 1. So minus 3 plus 0. Therefore this is just equivalent to 9 over 2 x squared minus 3. Now another rule in finding the derivative of a function or functions is the derivative of a product. So the derivative of a product of two functions with respect to x, let's say one function is u times another function v, is just equal to u times the derivative of v with respect to x plus v times derivative of u with respect to x. So let's say we're given this function x plus 2 times x plus 3. So let's say x plus 2 here is our u and x plus 3 is v. Now we get the derivative of y, function y with respect to x. So the formula in finding derivative of the product is u derivative of v plus v derivative of u. So that means we copy the function u first, or expression of u, x, which is x plus 2. Then we get the derivative of x plus 3 with respect to x plus v, which is x plus 3, times the derivative of x, the expression x plus 2. So this is just x plus 2 times derivative of x plus 3, so that is derivative of x is 1 plus derivative of 3 is 0, then plus x plus 3 times derivative of x is 1 plus derivative of 2 is 0. Then we simplify that. Therefore derivative of the function y with respect to x is just x plus 2 plus x plus 3. Now we can simplify this further by adding like terms. So we can get rid of the parentheses first. So this is x plus 2 plus x plus 3. Then we add up x here. So that is x plus x is 2x plus 2 plus 3 is 5. So therefore the derivative of that given function is equal to 2x plus 5. How about we're given this function y equals x to the 4th plus 3x times 3x minus 2. And we get the derivative of y with respect to x. So again, that is u derivative of v plus v derivative of u. So let's say the first expression is ru and the second one is v. So we copy u, which is x to the 4th plus 3x. Then we get the derivative of 3x minus 2. Then plus v, which is 3x minus 2, times the derivative of u, which is x to the 4th, derivative of x to the 4th plus 3x. Then this would become x to the 4th plus 3x times derivative of 3x minus 2. So that is derivative of 3x is 3, because that is a constant and a function. 3 times derivative of x is 1, so that is 3, minus derivative of 2 is 0. then plus 3x minus 2 times derivative of x to the fourth plus 3x. Derivative of x to the fourth, we use the power rule, so that is 4 times x to the 4 minus 1. 4 minus 1 is 3, plus derivative of 3x, which is 3. Then we simplify this. Okay. So we have dy over dx is x to the fourth plus 3x times 3 plus 3x minus 2 times 4x cubed plus 3. The first expressions here, we just distribute 3 to x to the fourth plus 3x. So this would become 3x to the fourth plus 9x plus, okay, we can do FOIL. We can use the FOIL method here. So we multiply 3x and 4x cubed. That is 12x to the fourth. Then negative 2 times 4x cubed is negative 8x cubed. Then 3x times 3 is 9x. Then negative 2 times 3 is negative 6. Then we group like terms. 3x to the fourth and 12x to the fourth here are alike, so we can add them up. So this is just 15x to the fourth. Then negative 8x cubed. It's alone, so we just copy it. So minus 8x cubed. Then we have 9x and 9x. So 9 plus 9 is 18. So this is 18x. Then minus 6. So this is the derivative of the given function y with respect to x. How about we're given this function y equals x to the fourth minus 2x cubed times x squared plus 2x plus 1. And we get the derivative of function y with respect to x. So that is dy over dx equals ru is this one, the first expression, and this is our v. So u, we copy u, which is x to the fourth minus 2x cubed. Then we get the derivative of v with respect to x, and v is x squared plus 2x plus 1 plus v, which is x squared plus 2x plus 1 times the derivative of u with respect to x, and our u is x to the fourth minus 2x cubed. Right, so we have x to the fourth minus 2x cubed times the derivative of this one. So each of the terms, derivative of x squared is 2x to the 1 plus derivative of 2x is 2 times 1, which is just 2, plus derivative of 1 is 0, plus this one, x squared plus 2x plus 1 times derivative of x to the fourth minus 2x cubed. Derivative of x to the fourth is 4, x to the 4 minus 1 is 3, so 4x cubed, minus 2 times derivative of x cubed is 3x squared. So we just simplify this. And we have x to the fourth minus 2x cubed times 2x plus 2 plus x squared plus 2x plus 1 times 4x cubed minus 6x squared. Then we further simplify. Okay, further simplify that. Okay, we can use the FOIL method here for this one. So dy over dx equals x to the fourth minus 2x cubed times 2x plus 2 plus x squared plus 2x plus 1 times 4x cubed minus 6x squared. Alright, then we multiply this one, x to the fourth times 2x, so that is 2x to the fifth. Then negative 2x cubed times 2x is negative 4x to the fourth. Then x to the fourth times 2 is plus 2x to the fourth. Then negative 2x cubed times 2 is negative 4x cubed. Then we have this one. All right, so we multiply that, each of the terms. We multiply x squared to 4x cubed, so that is 4x to the fifth. Then to negative 6x squared. X squared times negative 6x squared is negative 6 x to the fourth. Then this one, 2x times 4x cubed is 8x to the fourth. Then 2x times negative 6x squared is negative 12x cubed. Then 1 times 4x cubed is plus 4x cubed. And 1 times negative 6x squared is minus 6x squared. And now we group like terms. So we group all of those terms with exponent 5. So we have 2x to the fifth and 4x to the fifth. So they are like terms. We can just simply add them up. So 2 plus 4 is 6. Then 6x to the fifth. Then we have negative 4x to the fourth plus 2x to the fourth is negative 2x to the fourth plus 8x to the fourth is negative 6x to the fourth. So negative 4 plus 2 is negative 2. Negative 2 plus 8 is, that should be positive. And then we have x cubed. So negative 4x cubed minus, right, hold on. So we still have 6x to the fourth here. Sorry. That would be, okay, so we have negative 4x to the fourth. Negative 4x to the fourth plus 2 is negative 2. Minus 6x to the fourth, that is negative 8. The negative 8 plus 8 is 0. So that is just 0. And then we have x cubed. Negative 4x cubed minus 12x cubed is negative 16x cubed. Then negative 16x cubed plus 4 is negative 12. So this is minus 12 x cubed. Then minus 6 x squared. So our answer here is just, it should be done. So dy over dx is just 6x to the fifth, and we just remove the 0, minus 12x cubed minus 6x squared. So this is the derivative of the given function. So that's how to find the derivative of a product. Now, how about derivative of a quotient? So let's say we're given two functions. To get the derivative of the quotient of two functions, let's say we have function u over v. So this is just equal to v times the derivative of u over dx minus u times the derivative of v over dx over all over v squared. Okay, so you can just simply there's an easy way to, or a technique to memorize the formula. So you can do low d high minus high d low over low squared. So low d high minus high d low over low squared. So that means the denominator v times the derivative of the numerator minus the numerator derivative of the denominator, or all over the square of the denominator, right? Now let's say we're given this function y equals x over x plus 3. Then we get the derivative of y with respect to x. So that is v, which is x plus 3, times the derivative of u, which is x, minus u, that is x, times the derivative of v, which is x plus 3, all over the square of v, or x plus 3 squared. So this one here would just become, okay, no space, dy over dx is just x plus 3 times derivative of x is 1 minus x times derivative of x plus 3 is 1 plus 0, or just simply 1, over x plus 3 squared. So this is just x plus 3 times 1 is x plus 3, then minus x times 1 is minus x, over x plus 3 squared. Then x here cancels out, x minus x is 0, then we're left with 3. 3 over x plus 3 squared. Therefore, the derivative of that given function x over x plus 3 is just equal to 3 over x plus 3 squared. But if we're given this function y equals 3x over x squared plus 1, and then we get the derivative of y with respect to x. So this is just low, which is x squared plus 1, that is our v, then derivative of u, which is 3x, minus u, the 3x, times the derivative of v, which is x squared plus 1, all over v, x squared plus 1 squared. Right, and this would just become, okay, dy over dx equals x squared plus 1. Derivative of 3x is just 3. 3 times 1 is 3. Minus 3x times derivative of x squared plus 1 is 2x plus 0, or just simply 2x, over x squared plus 1 squared. Let's delete this. Right, then we have, okay, x squared plus 1 times 3. We distribute 3 here. So this would become 3x squared plus 3, minus 3x times 2x is 6x squared, all over x squared plus 1 squared. Okay. Okay, 3x squared here and negative x squared are alike, so we can just subtract them. This would be negative 3x squared plus 3 over x squared plus 1 squared. Therefore, the derivative of this function, 3x over x squared plus 1, is just equal to negative 3x squared plus 3 over x squared plus 1 squared. Or you can simplify this further. You can extract negative 3 here, or 3, or negative 3. Then this would become x squared minus 1 over x squared plus 1 squared. Alright, so that's all for now. We will discuss more rules in finding derivatives in the next videos.